Now that you've had some practice solving equations that had variables in the denominator, let's practice solving equations using the rules for logarithms. Here's the first one. See how you do. Since I have a sum, I'm going to use the product rule and rewrite this as natural log of 2 times x. Now I've got two choices here. Both of these could become exponents for a base of e. That's a fine strategy. I'm going to rewrite in exponential form, that is e to the first equals 2x. And then to solve for x, I'll simply divide by 2. Here's another. As it stands, I don't really have a good way of using a logarithmic rule right now, but I'm going to subtract log base 3 of x from both the right and the left. When I subtract log base 3 of x from the right, this will go to 0, just leaving it 2. And then over on the left, I have a difference. So I'm going to use the quotient rule and rewrite that difference as a quotient. Now I'll rewrite into exponential form and get 3 squared equals 18 over x. And of course this is 9. And so I'm going to multiply both sides by x. And that's going to give me 9x equals 18. Because if I multiply the right side by x, I can just reduce that factor in the denominator. And then I'll divide by 9 and get x equals 2. How about here? Now this one you can actually solve easier using inverse operators, but we're supposed to be using rules for logarithms. So I'm going to do that. The first thing I'm going to do is rewrite this factor as an exponent. Now right here we could raise both of these as exponents for a base of 10 and skip a number of steps I'm going to be doing here. But I'm supposed to be using the rules for logarithms, so instead what I'm going to do next is subtract the log of 64 from both the left and the right. When I subtract log 64 here, I'll get to 0. Here I'll get a difference. That gives me the idea of using the quotient rule. So I'm going to rewrite that difference as a quotient. Now to rewrite into exponential form, I'll use 10 with an exponent of 0 is equal to w cubed over 64. Now going back to my exponent rules, I know that this left expression is equal to 1. And then to solve for w, I'll first multiply both sides by 64. Once I multiply here, this will just reduce, leaving w cubed. And then I'll use inverse operators, that is, I'll use cube root to solve for w. Now we're going to move into some equations where we need to be a lot more careful about our answers. One of the things that's really important with logarithmic arguments is they always have to be positive. So if you ever get answers which will make the argument negative or 0, then you got to toss that. It's not a true answer in the real numbers. Give this one a try. Seeing that I have addition, I'm going to use the product rule and rewrite my arguments as a product. Next, I'm going to rewrite into exponential form. I'll have 2 cubed equals x times quantity x plus 7. Then I can distribute here and get x squared plus 7x. And 2 cubed is going to be 8. Now I have a quadratic equation, so I could use the quadratic formula or the zero product method. In either case, I have to subtract 8 from both expressions in order to get equal to 0. And looking at this trinomial, I'm going to try guess and check. And I see that it's x plus 8x minus 1. And that gives me the answers negative 8 and 1. Unfortunately, if I go back and put negative 8 in here or here, I end up taking the log of a negative number. And so this answer is out. On the other hand, 1 looks fine, and sure enough, the check looks good. How about here? Well, this difference makes me think of using the quotient rule, and then I can rewrite into exponential form, and e to the 0 will be 1. And then I'm going to multiply both sides by t minus 2 so I can reduce the denominator. And I'll have 2t minus 5 equals t minus 2. And now to solve for t, I'll subtract a t and get t on the left, and then I'll add 5 and get 3 on the right. To make sure this is an answer, I look back, and in both cases I get positive arguments, and so I'm satisfied it's probably going to work, and it does. How about here? This time I'm going to add log of the quantity x minus 3 to both sides and subtract 3 from both sides, and I'll get to here. And of course this sum makes me think of the product rule. And then I'm going to rewrite into exponential form as 10 with an exponent of 1 is equal to the argument. And I'll distribute and get x squared minus 3x, and then I'll subtract 10 from both sides so that my quadratic equation is equal to 0. Again, I'm going to try guess and check, and it does work. Now if it didn't, I'd go to the quadratic formula, and that gives me two answers, 5 and negative 2. Of course, this negative 2 makes me suspicious, and if I go back here, sure enough, I'll be taking the log of a negative number, so this one's out. On the other hand, if I go back with 5 looks like it's going to work, and it does. And here's our last one. Of course, this addition makes me think of the product rule, and then I'll rewrite into exponential form. I'll distribute and subtract 8 from both sides. In this case, I get n minus 4n plus 2 when I use the zero product method. That leaves me with two answers. Of course, this negative 2 makes me suspicious, and sure enough, in both cases, I get a negative argument, so that one's out. On the other hand, the 4 looks like it's going to work, and the check shows that it does. Well, that will conclude this video where we've solved logarithmic equations using the rules for logarithms.